Hello friends, Dr. David Katz, another COVID reality check, and I really look forward to the day when I can stop recording these because we're done with the pandemic and we don't need to be talking about it. But a couple issues we need to talk about now. The first is the immediate issue of the Johnson & Johnson vaccine and blood clots. And some of you may have had the J&J vaccine, some of you may be scheduled for it. So just a few things from altitude about this. First, there have been 6 reported cases of these blood clots and over 7 million doses of the J&J vaccine administered in the U.S. So if that were the sum of the data, and if in fact this is a causal outcome of the vaccination, the risk is less than 1 in a million. So the likelihood of anybody listening to this being directly affected is extremely remote. We don't yet know that that is the sum total of the data. There may be more cases. We also don't yet know for sure that the vaccine is causing these blood clots. How could that be? Well, just consider blood clots happen, and sometimes we don't even know why. They can happen because of oral contraceptive use, genetic vulnerability, other factors. And in a population of millions and millions of people, some number of those rare events will simply occur. If at the same time you are vaccinating millions and millions of people, just think of a Venn diagram. Rare, haphazard, random medical events that we may not be able to explain, or maybe we can if we do genetic testing. And the massive population being vaccinated, there's going to be some overlap. So for example, somebody who gets a vaccine during a huge global vaccination campaign will be attacked by a shark. That doesn't mean the vaccine causes shark attack. And somebody will be struck by lightning, and it doesn't mean vaccines make you attract lightning bolts. People do tend to think this way. Any bad event that happens after someone has had a vaccine is attributed to the vaccine. That's not fair. But I do think, given that we've seen a blood clot association with the AstraZeneca vaccine and with J&J, causal pathway is likely. And note, and this is really important, SARS-CoV-2, the virus, is associated with blood clot formation. And almost a year ago now, when I did my stint on the front lines during the surge in New York, we were routinely treating people already then with anticoagulants because there was such a heightened risk of blood clot formation. So it may be that it's not so much a problem with the vaccine, but stimulating an immune response to the SARS-CoV-2 spike protein. There may be something there that triggers the coagulation cascade, activates platelets, leads to blood clot formation. I'm not saying I know what the mechanistic pathway is. So far, there's no evidence that anybody knows. It's under investigation. I'm just saying that it's intriguing that this particular complication that has now paused 2 of the major vaccines being distributed around the world is a complication of the infection these vaccines are intended to prevent. And importantly, although any occurrence of an adverse event like this is a bad thing, the rate at which this occurs with the vaccine is massively less than the rate at which it occurs with infection. Although it looks like it's occurring in a different population, since the J&J vaccine is associated with blood clot formation in women, and some of them younger women. Further commentary on that I think is important. When an association between oral contraceptives and blood clot formation was first discerned in women, we thought it was just an adverse side effect of oral contraceptives. Ultimately, it turned out that a subgroup of women in particular have a genetic mutation that affects something called factor V Leiden. And my medical colleagues will recognize that term, the rest of you won't, but it has to do with the clotting cascade. And essentially this mutation creates a hypercoagulable state, a tendency to form blood clots, but it's only a partial step, and oral contraceptives completed the step, and the blood clots tended to form. Smoking also enhanced the risk. It may very well be that if there is a causal association between the J&J vaccine and blood clot formation, that it pertains to a subset of the population with some genetic predisposition. And since we don't yet know that, that needs to be sorted out. I definitely favor the delay in use of J&J while this is being ascertained. And if you've had the J&J vaccine and you're a couple weeks out, and by the way, My family has now been a beneficiary of all 3 vaccines in the U.S. My wife got the Pfizer vaccine. I got Moderna. It's just luck of the draw. And one of our daughters did get the J&J vaccine, and she's now weeks out and had a perfect reaction to it and is fine. So, again, the risk seems to be very remote. Much more needs to be learned. If you're scheduled for the J&J vaccine, I would wait. The dust should settle here. So I would reschedule. I know that's probably a pain because, certainly I found getting scheduled for the vaccine to be cumbersome at best. It should get easier and easier as we move through the campaign. But I would definitely hold off on getting the J&J vaccine until the magnitude of this risk is determined. And again, to be clear, anybody who was thinking that vaccines, would save us from the pandemic and involve no risk was looking at science through rose-colored glasses. Everything we do in biomedical science involves some risk, everything. It's regrettable, but it's the best we can do. We put in intra-aortic balloon pumps to save people in cardiogenic shock. It's a pretty high-risk procedure, sticking a big catheter in somebody's aorta. But it's done when, absent an intervention that intense, they're going to die almost immediately of cardiogenic shock. We use potent antibiotics that wipe out the microbiome. We don't want to wipe out the microbiome, but those potent antibiotics sometimes are the only thing that will save the life of somebody with a desperate infection. And on it goes. Everything in medicine involves risk. Vaccines are no exception, although they tend to be safer than almost everything else because they're really only useful at scale. And if you're going to impose something on a very large population, and in particular if you're going to recommend this for people who are currently healthy to prevent an adverse event, the risks have to be very low, like 1 in a million or less. And so far, what we've seen with the J&J vaccine looks to be in that general ballpark. The other thing that's really important to recognize is this is science working as it should. Finding that there are adverse events after you deploy a vaccine means that the surveillance systems are working. You go looking for adverse events when you do the initial studies. But think about a study, even in 100,000 people, that would be a massive study. Think about a vaccine study in 100,000 people for several months. Massive study. But if adverse events occur 1 in a million, you would only have a 10% chance of seeing one in a study of 100,000 people. In all probability, you wouldn't see any adverse events. And so it's only right to say, based on the initial studies, the ratio of benefit to potential harm looks to be favorable, and this vaccine is recommended. But then you want post-deployment surveillance, which is what we have now, where you continue to monitor as you reach not just 100,000 people, but 1 million and 10 million and 100 million. And you need to reach very large numbers before you can start to see very rare events. And it looks like this complication of the vaccine, if indeed it is that, it is rare and far too rare to find in a study of almost any size. That's how this works. The same is true with drugs, by the way. And sometimes it results in recalls, as was the case with Vioxx, rightly or wrongly. It's a complicated story, but essentially you study drugs, and even if it's perfectly transparent and perfectly honest and nothing but the world's best scientists are involved, you do a study in 1,000 people, 10,000 people, 50,000 people, 100,000 people, it's not enough to see adverse events that occur 1 in a million. And so you have to do this post-deployment surveillance where you look at the population scale. So this is science working as it should. Finding that there are adverse events attached at a very low level to vaccines is not a reason to distrust science. It's actually a reason to trust science. When science is imperfect, it acknowledges that. And we certainly know in biomedical science, in medicine, our knowledge is very far from perfect. And again, everything we do involves risk. So that's my take. I think the pause makes sense. I hope it's not too disruptive to vaccine deployment in general in the U.S. because we're at a critical phase in the pandemic. I'll talk about that momentarily. But it probably won't be because the J&J vaccine is only about 5% of the U.S. vaccine supply. And good news here, the whole new approach to vaccination, the mRNA vaccines, really does seem to be working extraordinarily well. So, it's interesting that many, many more people have received Pfizer and Moderna than J&J in the U.S., and yet we're not hearing about significant clusters of any kind of adverse event there. So these vaccines may be highly effective and especially safe. Again, I'm not going to reach a definitive verdict on this, and nobody should until time has gone by. But so far, they've lived up to the early promise, and that's quite exciting, because it may mean that from now on, there's a better way to make vaccines better, stronger, faster, safer. And if that's true, then it's a new day in our battle with infectious diseases. Okay, the issue of where we are in the pandemic, and again, I had very much hoped we'd be done having these exchanges by now. Why aren't we? Well, apparently many more people than met the eye managed to stay away from SARS-CoV-2 until quite recently in the U.S. So many young people in particular who were not formerly exposed are being exposed now. But I think there may be more to the story. And it has much to do with the development of all these new strains. One of the things that I talked about in these prior videos is the partial immunity conferred by common cold coronaviruses. So people who had memory T cells as a result of common cold coronavirus infection in the past were at least partially immune to SARS-CoV-2, and that was contributing to herd immunity. If you get a new strain that transmits better, however, then that partial immunity may no longer be enough. So many people who looked like they were part of the herd immunity crowd suddenly may be part of the vulnerable crowd, and they may be getting infected. It's possible the same is true of people who had mild infections in the early going. So if a lot of young people in the U.S. had relatively mild bouts of SARS-CoV-2 with the original strain, and they're now exposed to the B.1.1.7 strain almost a year or maybe even more than a year later, they may have limited protection and may be vulnerable to getting infected again. And that's what we're seeing for the most part. Casualty counts thankfully continue to plummet, but high rates of transmission infection in younger people are occurring, and much of that is driven by the new strain. And in particular, so far, it's the B.1.1.7 strain, but we are at risk of winding up exposed to some of the other strains circulating around the world. I think the remedy is fairly obvious. Vulnerable people ought to be vaccinated. I definitely recommend that. And again, it's not because of rose-colored glasses. I know some of you are reticent about vaccines. I respect the basis for those concerns, but I would simply rebut that everything we do in medicine involves some risk. And the choice during a pandemic does not involve a risk-free option. The only risk-free option is not to be in a pandemic in the first place. In the real world, during a pandemic, every choice you make involves some risk. So what we're looking for is risk trade-off. What is the least risky approach? And it certainly appears that the vaccines are massively lower risk than exposure to the virus, particularly as we learn more and more about long-haul symptoms. And I say that as somebody who's got them. And I look forward to putting them behind me, getting over them fully, but I'm now close to 3 months after a mild bout of SARS-CoV-2. I felt sick enough to be mostly in bed for a few days, but there was never anything that was remotely ominous or scary about my infection. And yet, 3 months later, my olfaction is not completely back. I still have fatigue. I still have aches. I still have headaches. And frankly, I have difficulty concentrating for hours. I can do it. If we call this a brain fog, then I can concentrate and generate a light that dissipates the fog, but it hurts. Essentially hours of the work that I routinely did before is now taxing and painful. I don't much care for that. So again, this virus is not to be disrespected, and the risks of the vaccines need to be juxtaposed with the risks of the native infection. It's no joke. I'm a perfectly healthy person. I'm not old enough to be in the very high-risk groups, and yet 3 months later I still have symptoms. People need to factor that in. It's a common experience. So the reason that we're in this complicated phase of the pandemic, and by the way, the reason that predictions about when the pandemic is going to end keep proving wrong, mine and everybody else's, is because the line keeps moving. And that has to do with the development of new strains. It would have been advantageous, by the way, to get through the pandemic faster. Yes, the vaccines came in record time, but that was still a year. And in effect, there's a basic equation we can think of. The number of people infected with the virus, we can call that N, times the number of viral particles in each infected person, we can call that V, times the duration of the pandemic, we can call that T for time, equals M, which is the total number of mutations that occur. These are random mutations. But, just like they occur in our own cells, random mutations occur in the genetic material of the SARS-CoV-2 virus. They're random. This is not a thinking enemy. This is not something that's trying to outwit our immune system. It's a replicating machine. The simple fact is that a replicating machine will come to prevail if it replicates better than every analogous version of itself. It's that simple. It's just, essentially whichever version of SARS-CoV-2 replicates best takes over. Well, which versions replicate best? The ones that are really good at infecting people and spreading. So any random mutation, and again, random mutation, it's not like there's a thoughtful contest between our immune system and the virus. Our immune system is doing what it does. The virus just exists, and it's subject to random mutation. But the numbers favor the virus. And so we're in an arms race. And let me provide a little numerical context here, although the numbers are mind-boggling. If hundreds of millions to billions of us are now infected, and that indeed appears to be the case, that more than 1 billion people around the world have probably been exposed. We don't have documentation of that, but looking at the surge in India, where the population is over 1 billion in just that one nation, and testing is pretty rare, so how many people have been infected, nobody really knows. It's very probable. We know for sure that hundreds of millions have been infected around the world. It's probable that it's north of 1 billion. Well, if more than 1 billion people have been infected, and if everybody infected has hundreds of millions to something like 1 billion or more viral particles, and we do, 1 billion times 1 billion is a quintillion. And that's not a number you hear very often. 1 billion billions. Now imagine if random mutations occur pretty routinely in any virus, but let's say that only 1 in 1 million viral particles is subject to a significant mutation. Well, if 1 in 1 million is subject to that mutation, then in a population of 1 billion viral particles, there would be 1,000 of those random mutations. And now let's just say that 1 out of 1,000 mutations happens to be advantageous. So that's just 1 out of 1 billion viral particles, 1 advantageous mutation in a population of 1 billion. I hope I'm not losing you, okay? Well, in a quintillion viral particles, there would be 1 billion of those advantageous mutations. I'm not saying these are the correct numbers. I'm just showing that when the numbers are this vast, the likelihood of there being new strains based on random mutations that confer an advantage is exceedingly high. You wouldn't expect anything else. Not because random mutations are common, and not because advantageous mutations are common among the random mutations, but because in a number like a quintillion, even exceedingly rare things that happen 1 time in 1 million or 1 time in 1 billion, are still going to happen 1 billion times. It's incredible. And it's not just that there are quintillion viral particles in circulation now. So, more than 1 billion times the total number of human beings that have ever lived is the number of SARS-CoV-2 viral particles that are circulating right now. But the lifespan of a viral particle is a few days, so there's a new generation, another quintillion, every few days with a whole new opportunity for a new batch of mutations, and on it goes. All of this to me means we really should have tried to get through the pandemic as expeditiously as possible while minimizing risk. And that takes me back to the argument I made in the beginning and stand by to this day. Total harm minimization by means of risk stratified interdiction policies because, frankly, when you're in a pandemic this long, unpredictable things start to happen. And in the beginning, we knew what the strain was. We had a good handle on the risk differentials. We knew less about long-haul symptoms and so forth. So we would have been taking some chances. But it's perfectly clear to me in retrospect that selective exposure of the population would have been better than the haphazard exposure of the population we've suffered with the very high casualty toll. In any event, the line does keep moving. We're not in the same pandemic now that we were in a couple of months ago. The new strains keep changing the rules. The herd immunity that we were approximating may require a different level of protection now than it would have if we were dealing with the strains we had before. And this argues now, as it did all along, for getting through the remainder of the pandemic as expeditiously as we can, through a combination of being careful and cautious and making appropriate use of, we have a new puppy, making appropriate use of vaccines. So again, there's always more to say, but particularly with a puppy barking in the background, I think it's time for me to wrap this one up. So, again, I do think the pause in the J&J vaccine is warranted. I don't think finding that there are some adverse events associated with the vaccine should be a shock for anyone. I don't think it implies anything wrong with the scientific process that these are potential adverse responses not seen in the original studies and only showing up now. That has to do with their frequency. At a very low frequency, the only way to see these kinds of adverse events, even if they are a causal result of the vaccine, which is not yet proven, is for enough people to be exposed to see them. And then the minute you spot them, reassess, which is exactly what's happening now. So again, if you're scheduled for the J&J vaccine, postpone that or try to get one of the others where we're not seeing these adverse events. But my prediction is that at some point, and I don't know how quickly this will happen, we will identify specific genetic markers and risk factors associated with this response to the vaccine. And so this won't pertain to everybody. This will be a select group in the population that shouldn't get this particular vaccine. And again, science is always learning from both its advances and its unfortunate mistakes. Good news, however, is millions upon millions now have received one or the other of these vaccines, and the rate of complications overall appears to be impressively low, and the rate of protection appears to be high. So this is definitely a significant advance. Okay, I think that's what I've got for you today. By whichever means, I hope you stay safe and well. And I'll look forward to your comments as ever and react to them as best I can, assuming that they don't beat up on me too badly. And I will check in again as the need arises and I decide I've got something to say. But again, my sincere hope is we get through this pretty quickly and the reason to record more of these videos goes away before too long. Take care.